Thanks. I'm Carrie Reed. I'm with the Influenza Division at CDC. This is a quote recently attributed to one of our recently retired influenza directors at CDC. And today I'm going to use some non-digital data to show some examples of influenza and highlight opportunities and challenges it provides for digital data. First, while in temperate parts of the world, influenza displays a strong winter peak, it doesn't tend to peak at one consistent time each year. This graph shows peak flu weeks from US surveillance since 1982. Each bar shows the number of times activity peaked in that week. Around half of seasons peak during February, but peak activity has occurred anywhere from late November to late March, and pandemics such as with 2009, shown in red, may occur at other times. Another characteristic of an influenza season is the annual disease burden. Estimates of influenza-associated deaths and hospitalizations have been refined over decades, but the average estimates of 24,000 deaths and 250,000 hospitalizations in the US tell only part of the story. When you consider annual variability, recent estimates have shown over 10-fold differences in deaths and 5-fold differences in hospitalizations, depending on the season. Both of these factors highlight some opportunities for digital disease detection, namely to provide earlier insights into the timing and intensity of an influenza season or a pandemic. As the field continues to advance, though, it's important to keep in mind also some of the challenges. One challenge is in the geographic representativeness and granularity of digital data, which can be limited if geographic information is not disclosed by the user or not reliably available in that data source. Geography matters, however, as influenza is not homogeneous across the country. This shows 1 week of a map we update weekly in our influenza surveillance report to show how states vary in the intensity of ILI activity across the country, from minimal in green to high in red, and this varies over a season. The timing of a given season may also vary between states. These graphs show the number of states that had a peak activity in a given week. A sample season is shown on the top and the 2009 pandemic on the bottom. Knowing just the national peak timing may not be useful, as states may peak anywhere during an 8 to 10 week period with a few early outliers, and many states will have already peaked and declining by the time the national peak occurs. Another challenge may be in the demographics of digital data. Two sources that have been used already, especially for influenza, are posts on social media such as Twitter or online health searches for information. But how well do these data sources reflect the underlying population? Recent surveys show that though all socio-demographic groups are captured, social media usage and online health searching are far more common in younger adults with higher socioeconomic status, which may not best represent persons most highly affected by flu, like people over the age of 65. This graph shows rates of flu hospitalization since the pandemic by year of birth. As age increases along the x-axis, rates of influenza hospitalization also increase. However, this can also vary from season to season depending on the predominant influenza virus, as rates of H3N2 in yellow increase by age much faster than for H1N1 or B. Inasmuch as this doesn't affect the ability of digital data to detect the general trend, maybe knowing that we expect older age groups to be more affected is enough. Or maybe we supplement digital data with virologic surveillance data for additional context. However, even the same virus in 2 different years can behave very differently. This graph shows data from the 2009 H1N1 pandemic and the 2013-14 influenza season, which was the first year the pandemic virus predominated again in the United States. The blue line shows the rate of hospitalization by year of birth during the pandemic, and the red line shows hospitalization rates from the same system during the 2013-14 influenza season. If you only had data that was heavily skewed toward younger adults, shown here in the middle of the graph, you may not have been able to detect any differences between the 2 seasons. Whereas children and younger adults had 2 very different years with opposite experiences in the 2 years. In light of these opportunities and challenges, the key to successful use of these data and tools that we're talking about is likely to be found in collaborations between digital data, epidemiologists, and decision makers who can each contribute their own perspective. Contributions about the nuances of the disease and what information would be useful for public health decisions can help focus existing tools in useful ways and identify the remaining gaps that may need some creative thinking and data sources to fill. Thank you.